Hi, everyone. Before we get started, I just wanted to make some quick introductions. So my name is Nicole Scott. I'm the project manager for the Agricultural Genome to Phenome Initiative, or AG2PI. AG2PI is supported by USDA NIFA, and we're also supporting this workshop series through a seed grant to the University of Arizona and Purdue. This is the third and final session in this series called Introduction to Scientific Computing. And Travis and Ariane and Nathan have rejoined us again to lead you through this topic, which is version control using GitHub. And I believe they're also going to review some machine learning with you today. With that, before we get started, I would like to mention that we would really appreciate if you could fill out a survey for us when you leave this workshop. As you leave the Zoom meeting, you should have a survey pop up on your screen. And what we do with the survey is we use the feedback to improve our workshops. And there's also an opportunity for you to suggest future ones if there's a topic that we'd really like to see AG2PI lead you through. So with that, Travis, would you like to get started, or Ariane, are you getting it started?
Yeah, I can get it started.
Okay, sure.
Thank you so much, Nicole. Welcome back, everyone, to the third and final workshop in this series. We're very excited to talk to you guys about version control, and Aaron's going to go over some machine learning today. So let's get started. All right, can everyone see my presentation fine? Hear me okay? Sounds good. All right, so as I said, welcome back to the Intro to Scientific Computing for the third workshop today. My name is Travis Simmons. I'm an undergraduate biology major at the College of Coastal Georgia and a research data specialist at the University of Arizona's Pauli Lab. So if you guys weren't here for the last few weeks, in the first session, we went through the introduction to Python and Jupyter notebooks. Then we did some command line stuff with shell scripts, did some data analysis, and then we ran out of time right into that and ran out of time to do the machine learning. So we're going to do that machine learning today at the end of this workshop. And today we're going to be talking about version control using GitHub. So over time, programming, the way we program and the way we interact with computers has changed dramatically. So in the beginning, when we were writing code for computers, you had to physically plug stuff in and manipulate things. Then with languages like Fortran, punch cards were used that you can see on the top left there. And then some more languages, like early languages like BASIC, were created. And so you could code for a computer on a computer. And this was really powerful, so you didn't have to use these punch cards anymore. And now we don't work in isolation anymore. We don't just sit and code and write our own code and no one else sees it. Usually you're going to be working on a team setting, whether that's in a big lab or in a large tech company or in any kind of data that you're going to be using. Generally, you're going to work with a group of people who are all collaborating on the same code base, at least, if not on the same actual piece of code or on the same file. And that can get really messy and hard to do. I know I have trouble managing my files when it's literally just me trying to write an essay or something. Lots of the times you can end up with something like this, where you have a first draft, a second draft, a final draft Travis edits, a final draft final, a final draft, until you actually get to your finished product. So you end up with this giant web of edits or versions that need to be controlled. So that's what version control is when you're getting from the beginning of creating a document or a script or a bunch of scripts to that finished product. There's going to be a lot of steps along the way, and we want to avoid this. We want to avoid all the versions just clogging up a computer and not knowing where changes were and who made them. Version control solves that problem. So version control to the rescue. Giant companies and small labs alike use version control, such as Google. Here you can see on these little tiles are all different repositories of code. And a repository is just, you can think of like a folder that pertains to a certain topic. So here on the bottom left, We have style guide is one of their repositories or repos. And if we were to go in there, we'd see all the code that's related to style guides for Google. And you're already using this tool, which is GitHub. There's a lot of different tools that you can use to do version control. We're going to be focusing on GitHub today. Some other ones are like Bitbucket. You may run into those out there in the wild when you're doing code. But last week we looked at this repo and we had you download it and do some stuff with it. And don't worry if you weren't here last week, we're going to do all that today as well. But as you can see here, we have a bunch of different scripts, including images, session 1, session 2. These are all folders with different scripts in them. And then you can see on the right-hand side where you can see all the different history of people making changes. You can see some were 6 days ago, some were 5 hours ago. And you see a lot of information here. So the point is, this is a whole repo, and you guys are already interacting with it. So generally, let's get a more visual understanding of what version control is. So if you were just at your house writing a essay, let's say, or a script, you would start and you would create the document or script, and then you would keep working on that same file until it's finished. That's one way to go about working on things, right? Never making a copy, never making that Travis edits file. That's one way to do version control because you're controlling just a singular version, right? Well, when you use a version control tool such as GitHub, you are able to save different versions as you go along, track those changes, and merge them together to create your final script. And all this is also stored on the cloud, whether privately or publicly. And so that's a powerful way to use version control if you're just developing by yourself. So it doesn't have to be just with a team. So you could make a change and then you have version 1, make another change, have version 2. And then let's say in version 2, you broke something in your code. You could always revert back to version 1, and GitHub keeps up with all that for you. However, what if someone wanted to on your team wanted to also collaborate with you on this script? Well, you can do a thing called branching. So can you guys see my mouse? Arian, do you mind unmuting to tell me if I can see the mouse?
Yes.
Okay, sweet. So let's say you created a script and you're working on it and doing some development, and then a person on your team says, hey, I want to develop a function, or I want to add a paragraph, or whatever it is, right? They will do what's called creating a branch. And creating a branch is basically creating a copy of that repository, creating a copy of all the code there, and then they can make changes parallel to you while you're also making changes on your copy. And those changes will also be tracked. Then once they get done making changes, they can do something called a pull request, which basically says, hey, I'm done making changes. I would like to merge those changes with your original script. And we call that original timeline the main branch. So we're creating a pull request to merge our changes with the main branch. And I know that's a lot of terminology, but we're going to go over it again and again today. So just in general, version control allows a lot of people to collaborate, make copies, make their own changes, and then merge all those changes together at the very end. An example of this temporary style of branching is shown here. So in this repository, we can do this little drop-down menu, and we can see all the branches that are currently active. So each one of these is a different person trying to make one single change, right? So this person right here has a branch where he's just adding a license. So all they're doing is creating a copy of all this code, changing one thing, which is adding a license, and then they will merge it back into the main branch. And so all these are different people developing and going to merge their changes back into main to eventually have one script that has all the changes incorporated in it. Another style of branching is to create permanent branches. So if you had a script and you needed 2 different versions of it, you could make a branch, make your changes, and then never merge those scripts back together. So we see that represented here, where you have a season 10, season 11, season 12 branch for this code. So this code does the same thing, but slightly differently for each of our seasons. And we wanted to keep all those separate. So these will never be merged back into branch. So we have 3 different versions of this code. And that's another way to go about doing version control with branches. And it's up to you and your team and yourself to decide how you want to manage all this different stuff. And we can talk a little bit more after this if you like about the pros and cons of each. So how do you do all this? How do you create branches? How do you do version control just for yourself? Well, last time we talked about using graphical user interfaces and the command line interface to interact with file systems on your computer. And you do the same thing with Git and GitHub. So GitHub is the online tool that I was just showing that's pictured on the left. And on the right is a picture of the command line interface. And you're going to use both of these to do version control. You're going to use an application called Git, which is what GitHub is built off of, in order to interact with all your versions, to make changes, and to track all those changes. So instead of before, when we had to kind of pick one of these two in order to explore our files, we're going to use a combination of these two together to do our version control today. So let's kind of get oriented in a singular GitHub profile and what that looks like and some of the terminology here. So here's my GitHub profile, and here you can see 6 different tiles. Each of these are a repository where there's code stored and tracked the changes of for a particular thing. So like I have this plant clustering script, and all in there is all the code that I've written for plant clustering. So if we went into this repo or repository, we see all these different files that I have, that all the changes are being tracked. We can go look at our branches if we want. So this is just one repo, and we're going to call this a remote repository. Remote because this stuff doesn't live on my personal computer at my house. This is all stored on the cloud on GitHub servers. So it's a remote repository. I don't interact with it on my local machine, but we can make copies of it and interact with it and then upload it again to these remote repositories. So just keep in mind, when I'm saying a remote repository, I mean a repository of code that is up on GitHub servers. So we're going to use the graphical user interface in that way to explore code, find repositories, and stuff like that. We'll use command line using Git in order to interact with those remote repositories from our machine. So today, the first thing we're going to do is we're going to learn how to version control your own code with GitHub and get you set up with your first repository. And then also work on your collaborators' code. And what we're going to do is have you guys contribute some code to our project. And so you can see what that's like if you ever wanted to have a collaborator and be able to work with them. So first thing we're going to do is we're going to make a practice repository where we create a repo and add some code. So the first thing to do with that is we're going to all get signed up for GitHub. All right, give me 1 second here. All right, if everyone could navigate to github.com. And Aaron, if you don't mind sending that in the chat, just github.com. And what you're going to do is you're going to click in the top right corner where it says sign up. And then you're just going to follow all these prompts. It's going to ask you to put in your email, to create a password and a username. And then it's going to send you a code to your email and send you a code to your email so you can verify that. And I'm going to give everyone about 5 minutes to just go through and get a GitHub account set up. And if you already have a GitHub account, then you're good to go. Just chill out for about 5 minutes, and then we will get back together then. In the meantime, I'm going to sign into a GitHub account, and I'll show you guys what that screen looks like so you'll know when you're done signing up. So whenever you see a screen that looks kind of like this, you'll know you're done signing up. And then if you could give us a thumbs up whenever you get to that point. And I'll leave that up just so everyone can see. Now I'm going to give us about 5 minutes here for everyone to get that set up. And feel free to unmute or join the support channel if you're having trouble getting signed up for GitHub, or just let us know. And all right, and I can't see the chat or anything, so just let me know if anything comes through.
Sure, sure.
All right, I'm going to stop sharing. So if you guys need to see that screen again, let me know in the chat. In the meantime, how many, if you guys are already have a GitHub account, do you guys want to give a thumbs up in the chat just to see who all has already has GitHub? Fahad, Mashoud, Wellison. Nice. Okay, I see a lot of you guys. That's awesome. Luis. Awesome, awesome.
Travis, there's a question in the chat saying that Fahad is asking, would we be able to follow this workshop on GitHub desktop app?
You can, not exactly. If you're already using GitHub Desktop, today what we're basically going to be doing is creating a repository and pushing some changes to that repository. So I'm sure you could do that on the desktop app. I mean, that's what it's for. So if what I'm going to be showing and going through won't be exactly what you would do, but yeah, you could follow along and just be slightly different. All right, we've got about 1:30 left of giving you guys time to get it signed up. So I think we'll be moving forward shortly. All right, so we've got about 5 minutes going there. So let's get started again. So hopefully everyone was able to get to this screen or to your version of this screen. You'll have a lot more on here if you've used GitHub before. But what we're going to do, actually, before we get to that, I'm going to send a link to the chat of a README that has all the steps of everything we're going to do for the GitHub stuff from here on out. So it'll show you everything we're going to do in case you get lost, or for the people who are following along over recording. So feel free to check that out and follow along with us. So if we go back to this screen, what we're going to do is go over here to this button on the left. It's a green button that says Create Repository. All right, so here's what it looks like to create a repository. We're going to give it a name, and I'm going to call it test_repo. So that's going to be the name of a repository. And then we're going to click this button here that says add a README file. And a README file is usually where you put your instructions for how to run the code that's in that repository. Just like this link that I just sent, the README shows you how to go through the workshop. So you can use it for whatever you'd like. Then we're going to click this green button down here that says create repository. If you were in a lab where you wanted to keep everything private and you didn't want everyone to see, you can change right here to public to private. So whatever code you put on here does not have to be open to the public, but today we are going to make it open to the public. So click create repository. And congratulations, you have now made a repository. So here's a place where you can keep up with all your code for the test repo. So for this workshop or whatever you'd like to do. Let's see. All right, so there's certain things you can do, like we were talking about, where you can make a use the graphical user interface to do stuff online. So you could add your files here. You could upload files, and then you could also edit files using the graphical user interface. So we can make a change by clicking the little edit thing. Then we can do a thing called commit changes. So you can make changes using the graphical user interface, and those changes will be tracked. But today we want to try to use the command line, which is what most people use, to do this version control. So in order to use the command line, we have to do one more setup thing, which is making an authorization token. So you can associate your terminal command line changes with GitHub. So what we're going to do is go to the top right up here where you see a little logo. It's your this is your profile picture if you've uploaded one. You're going to click there, and you're going to go to settings. All right, now we're on our settings of our GitHub profile, and we're going to go all the way down to developer settings. All right, so we're going to click developer settings. Then we're going to click personal access tokens. And again, this is going to be all on that README that I sent in the chat. So I have one token here that I've already created, but you would go up here to click generate new token. And again, this is going to allow you to make changes from the command line on GitHub. So if you click generate new token, you can make a name for it. So I put workshop, and then you're just going to check this box right here. All right. And again, this is all in that README. So then we're going to scroll down to the bottom and click generate token. I'm not going to do that because I already have a token, and also I don't want to give you guys all my information. So when you generate that token, there will be a string of numbers and letters that come up. That is really important for you to keep private, and for you to save somewhere on your computer for future use and for the rest of this workshop. And like I say, already created one. And then let me stop sharing for a second. And can I get some thumbs up if you were able to create a personal access token? Fred, nice. Fred, welcome back. Got 4 people, 5 people. Okay. Awesome. I'm seeing some a few people here able to create the personal access token. Again, if you weren't able to, feel free to look at that README. It'll show you how to do that. So let's see. Now we're going to make some changes to that repo that we created just a second ago. So there's kind of a workflow that you're going to be following anytime you want to make a change to one of those repos and do version control. First, you're going to clone the repo. You're going to pull any recent changes. You're going to make a commit, and then you're going to push those commits. And that's a bunch of jargon that we're going to go through, and I'll show you how to do each of these things. But after you do this a few times, you will have it down, and you'll be making changes like a pro. So the first thing we're going to do is a Git Clone, which takes a remote repository. You run the Git Clone from the command line, and it creates a local copy of that remote repository for you. So let's navigate to our repository. So let's go back to this little icon on the top right and go to your profile. All right, on your profile, you'll have one tile here that says test repo, or whatever you named it just a second ago. We're going to click there. Then we're going to use this little drop-down button and this green code to copy the link right here. So we're going to click copy. All right. So now we're going to open a terminal. So however you get to your terminal, we'll open it up. Let me make it a little bigger for you guys. All right, so now we're on our terminal and we have copied our repo's link, right? So what we're going to do, we're going to Git clone that repo. So we'll have a copy of it. So if I do ls right here, I see that we're in a completely empty directory. How do I get to my terminal? I'll see in the thing. It depends on what operating system you're on. And if you're not using Windows or Mac, do I need to install the terminal? Yes, so last week was what we went through was installing our terminal if you're on Windows. If you're on Linux or Mac OS, then if you're on Linux or Mac OS, then you should be able to just launch a terminal. But if you're on Windows, then you need to install WSL, which we covered in our last workshop. So I would direct you to our last workshop recording in order to get that set up for you. And if you go to that repository I sent with the README in it, if you go to workshop 2, then there is a README showing you how to install the terminal on your Windows machine. So yes, but okay, so we're in an empty repository, and now we're going to do git clone. Then we're going to right click and paste that. All right, then we're going to click enter, and you're going to see some printouts. And if we do ls, we'll be able to see that there was a test repo downloaded onto our machine. So is everyone able to run that command? Again, again, all of this was displayed in that README for you.
Travis, I guess there's one person at least having an issue with installing or using Git. It is possible that you don't have Git installed on your system. So for that, you can go to the, like, I can find a link for installing the Git on your computer, on your terminal.
Right, would it just be sudo git apt install?
Yeah, that's one of them for Linux. For other versions of operating systems, there are other code. Let me see if I can find some. And there's another question in the chat.
It really depends, Faith, on what version of Windows you're using. And so it could take a very short amount of time, or it could take a very long amount of time. Like I said, let me send the README for Workshop 2 into the chat so you guys can get that set up.
I just shared a link in the chat for those who doesn't have Git install. You can install using that. And again, just as a reminder, we are going to have a breakout room set up for you guys. If you have problems, you can just join that breakout room, and Nathan would be here to help you with that. If you're having problems joining the breakout room, the support breakout room, just let me know. I can take you to that breakout room.
If you set your repository to private, in order to change it to public, you can go to settings right here. And then go all the way down. You can click change repository visibility. And then that'll let you change from from private to public or back. All right, can I get some thumbs up of anyone who was able to run that git command? All right, see about 5 people. All right, so hopefully everyone's able to get that downloaded. And if not, again, we have the breakout rooms if you'd like to join there. And Nathan, if you see anyone join those, if you don't mind popping over there and helping them out. Could you please show again how to connect to GitHub by terminal? Are you talking about how to? I'm not sure what you're asking there. So again, all we've done is Git Clone and then that link to the GitHub. And if you're having trouble using Git, then Arian sent the link just a second ago that shows you how to install it. All right, so let's move on. And if you guys are still having problems, feel free to check out this recording and the README. And I'll add a section on the README about installing Git. If you went through workshop 2, we installed Git then, so that's why we weren't going through that today. But I know some of you, this might be your first time here. So here we are, we have our test repo. And so we're going to do cd, and then we're going to type the name of that, test_repo. And now we can see, if we do ls, we can see we have one file in there that's that README. And if we look on GitHub, that is correct. We have one file in our repository that's a README. So now what we're going to do is we're going to make a change to that, or we're going to create a file. So last time we installed VS Code. So if you haven't got that installed, again, go to the README for session 2. And if you do have it installed, we can do code here, and it'll bring up a way to interact with this repository using VS Code. Or if other people are comfortable using Vim, you can do Vim and then a file.py. We're just going to make a Python file today. But I'm going to do the code thing using VS Code because that's what we did last week. So doing that, we'll launch VS Code. And all we're going to do is make a new file. So we're going to come over here to the top left and click this new file icon. And I'm going to call it test.py. So now I have two files in this repo. This is my local copy of that repository. That's README and test. I just received a message that says, can I please repeat the step? So I am inside the repository from the command line, and there was just the README. Then I did code period to launch VS Code. You can also launch it from the icon if you have it already installed. And if you don't have it installed, we installed it during session 2, and we sent a link to that just a second ago. So if we bring that up, we have this empty Python file. There's a new file. I'm just going to write a print statement. So we'll say print, open parentheses, open quotes, and then I'm going to say hello version control. Then I'm going to do file save or control S to save that change. And then we can exit out of VS Code. So if I could get some thumbs up in the chat if you were able to create a script inside of this repository. See one thumbs up. All right, or is there anything particular that you guys are getting stuck on that's keeping you guys from doing that? I see 2 thumbs up. Feel free to unmute and ask any questions. Can I pull the command line up? For sure. And again, that this link right here would be the one to your repo that you created just a second ago. Hey Jerome, like I said in workshop 2, if we could send that link again, maybe. Let's see. Session 2. Should show you how to install that. Code doesn't work for you either. Okay. If you go navigate to the repository and then just let's see, Do you know, Arian, do you know the other way to open VS Code from the command line besides the code?
No, that's the only way that I know to open VS Code. But if you have your if you have WSL installed, you have to open up that WSL Ubuntu. That's gonna take you to your terminal, and then within the terminal, you should be able to use code.
Yeah, try just opening it if you have WSL installed from the little icon. And then like Fred said, try just running code and see if that works for you.
And since we are going to only modify just a file, we're not focusing on any of the VS Code features, so you can edit that file using your notebook or any other application.
For sure. And again, all this is going to be on the README for session 3. All of the commands that we're writing and everything is in that README that I sent earlier. All right, I'm going to stop. Is there anyone, if everyone could give a thumbs up, and Arian, if you could check, because I can't see the participants, if you were able to create a file in this repository. I'm on Ubuntu, code didn't work for me. Okay, try just I did install. Try just writing the word code, just CODE, and see if that installs it for you. Doesn't show any error. And then code space period doesn't do anything. Code space period. All right, well, you can use, if you're on Ubuntu, you can just navigate to it using your file explorer and just create a file in there. It doesn't have to be through VS Code or through the terminal. That works fine. Nano or Touch would work. Vim, Nano, Touch, any of your preferred text editing interface. Sweet. Okay. So I think we've gone over most of that. So now we have a change locally. Now this change isn't reflected in our remote repository, it's just in our local repository. So the next thing we're going to do is we're going to do a Git pull. So a Git pull is always a good thing to do right when you start working. So anything that's changed remotely in that repository since the last time you did the clone, it'll update your local coffee to reflect those changes. So let's go back to our terminal and write Git pull. And as you can see, it says already up to date because all of our changes are reflected. Our repo matches up with the remote repository, aside from the changes we made. But the remote repository hasn't changed since we did the Git clone. So we're good to go. But if you were working in a team and someone made a change in the remote repository and you wanted those changes to be reflected in your local repository, you would do that Git pull. All right, So now we've made a change to a script locally. And now we're going to take that change and go through a few processes, a few commands in order to get that change up to that remote repository on GitHub. So the first thing we're going to do is a git add. So to do a git add, again, we see we have this test.py right here that we want to send up the changes to. So we're going to do git add test.py. All right. And then if we run git status, git-status, we can see we have one new file there. So that's exciting. We have a new file. It recognizes that we have a new file that's not up to date on our remote repository yet. So I'm going to type clean just so I can get all this a little cleaned up here for you. I mean clear, excuse me. So if we do git status again, we can see that we have that new file ready to be pushed up to our remote repository. All right, so we've added a lot. We can add as many of those changes as we want. We just changed one file, but we can add a bunch of different files. And then what we're going to do is do a thing called a commit. So we're going to do git commit and then the flag -m, and then we'll have a message for that commit. So a commit is kind of like a bundle of changes. You can think of them as, oh, I changed this file, changed this other thing in my local repository, and I'm going to bundle up all those changes, and then I'm going to push all those changes up to the remote repository. And then in the remote repository, your changes will be merged with whatever code is currently up there. So first we have to add all of our changes to a commit. So again, we have the one file right here that's ready to be committed. It says changes to be committed. So we're going to do git commit -m, an open a quote, and then we'll type a message. So we're going to say testing out changing a repo. All right. And we're going to click enter. And as you can see, we have one file changed, and all we did was add one line of code. And it's creating that file. So if we do git status again, we can see that our branch, our local branch, or our local repository, is ahead of the origin or main, which is the remote repository, by one commit. So we have made one change, we finalized one change that is not reflected in our remote repository. Please tell me who you are. All right, if you're getting the error that was just put in the chat, you can run the code that I will send out. Arian, do you know if the quotes need to be in there for that username command?
No, doesn't have to be there.
So if you're getting that that error there, you can run this code and replace those curly brackets and that text with your username that you gave GitHub when you signed up just a few minutes ago. That should work. All right. Can I get a few people to give me some thumbs up if when you run git status, you're getting the same message that I am? And Arian, if you tell me if there's some thumbs up, I can't see the people.
Sure. Right now, there are no thumbs up. There's one from before.
Again, feel free to go to the support room or to check out the README if that would help you guys out. I'm going to send the README one more time in the chat.
We had 2 thumbs up.
Travis,
For sure.
I still get a warning when I run the command, but now it worked. Is that warning something that I should take care? It just says that my email and my identity were configured automatically based blah blah blah, and it says something like git config so -- global username your name. I don't know why is appearing. It didn't appear like yours in your terminal. It showed those extra information.
Yeah, as long as when you do get status, it shows what it's printing out here. If it shows a warning or anything like that, it should be fine. When we do this next step, if it yells at you, then maybe we'll take a look at it. But that sounds
Okay.
fine to me.
Yeah, no, last time it didn't work. It asked me who I was, like the same error in the chat. But now it worked with that warning message. Thank you.
Sweet, sounds good. All right, sounds like we've got a few people good to go on that front. And again, this will be recorded and we have that README. So I'm gonna do clear to erase all that. And we can get started with our next part. So git status. So now we've run our commit and we finalized some changes. And the last thing we're gonna do is to push those changes. So we have one or more commits. We can do a bunch of those processes and have different messages with them. Generally, you're just going to do one group of changes for a commit. And today we just have that one commit that's adding that file. So we're going to push that commit so you can think of those changes as a package. And we're going to push those changes up to the remote repository. And that'll take all those changes and add them to that remote repository. So we're going to go back to our terminal. And we're going to do git push. Then it's going to ask for your username. And my username on this account is intro to computing 321. So I'll put that in. And then the password is not actually your password. It says it wants your password, but it's actually lying. What it wants is that code that we generated earlier. So copy and paste that code into this password. And then click enter. And that should give you a printout something like this, where it went through all the objects in the repository and made all those changes. So hopefully some of you can run that. And then if we go back and look at our repository, if we refresh this page here, we see we have our new file, the message we put with the commit, and then when we made it. So let me go back to the command line so you guys can see that. It's just git push. And were you guys able to run that fun? You got one thumbs up from Fred, awesome. How do we get passwords? So that was that authorization code that we generated at the beginning. If you check out that README that's up at the top that I just sent in there, it'll show you how to generate another authorization password. But I can show you real quick. It is under your badge right there. You go to settings, developer settings, personal access tokens, generate new token, you name it, and then you check this box. Then click generate token and it'll give you a string of letters. Copy that and save it forever. You'll never be able to see it again, and don't give it to anyone. And then that's what you use as your password when you're making that push. Oh, I was not screen sharing when I showed you that. So again, if we go to this badge right here, then go to settings, go down to developer settings, personal access tokens, generate new token, give it a name, click repo, generate token, and it'll give you a unique key that you need to save and never give to anyone, and then that's what you use as your password. So hopefully a few of y'all were able to get that working. And so congratulations, you've just made your first commit to GitHub. And you can do this over and over again, modifying files, doing Git clones and Git pulls, modifying a file, pushing it back up, and those changes will be automatically integrated into your code. And at any time, you can revert those changes back to any point through the entire life history of your repository. So that's how you do that if you were just doing it by yourself. Then we're going to do one other thing. If I think we're going to have time, yeah. We're going to do one other thing here. We're going to contribute to an open source project, which is our project, which I'm very excited about. So we're going to create a fork, which is just like a branch basically, except when you don't have permissions in the repository. You're going to make some changes, and then you're going to give me a pull request. And I'm going to show you what it looks like on the other end to merge your changes. And so we're going to do that now. So let's see here. I'm just going to go back to the profile of this page, and then let me send a link in the chat. All right, so if everyone could go to this link, this is a repository for this workshop. All right, and then we're going to click fork in the top right corner. All right, then we can just hit create fork. All right, so now you have your own copy of all of the code that we used for this workshop. As you can see, it's in your usernames area on your profile, and then has its regular name. So this is your code. You can mess with it however you want. Then once you want to do that pull request to merge it back in with our code, you would click contribute right here. So we're going to do, again, the same thing we did with our personal code. We're going to do this little drop down with this green code button and copy this link. By clicking that button right there, will get us that link. Then we're going to go to the terminal. I'm going to go back to do cd ... to get out of that test repo that we made just a second ago. And then we're going to git clone the repo we just forked. So git clone, and then that link that you copied just a second ago. All right, if I could get some thumbs up in the chat if you were able to do that. Aaron, does it seem like there's a few people with thumbs up?
Yes, there are a few people with thumbs up.
Awesome, that's great to hear. So as we can see, let me clear. Now we have two folders. We have the test repo and then all this code, right? So we can cd into that repo we just cloned. So you can type it out, or you can type AG and then tab and it'll complete it for you. So CD into that. And if we do ls, we can see we have code inside of that. And we're going to CD into session 3. CD session 3. If we do ls, we can see we have a few folders here. We're going to CD one more time into response scripts, CD response scripts. And you can see there's a few Python files here from me testing this earlier. Both sides that it should be empty. Then we're going to use touch, vim, or VS Code to create a file in this place, just like we did a second ago. So code, period. I'm going to create a file. Then I'm going to say example response.py. So now we have an empty Python file inside of this repository. And what I would like each of you to do is to type a print statement. So print, open parenthesis, open quote, and then give us some quick line of feedback about the workshop. Did you have fun? Did you not have fun? Did you learn a few things? Did you not learn a few things? Just a quick something. So I'm going to say some feedback. So write that in and then Control S to save or file save. So now we've updated this Python script. All right. So then we'll exit out of here. And if we do ls, we can see we now have this example response. All right. If I could get a few thumbs up, if folders in place but not updated. Yeah, if you go into that repo, and so that is not your forked repo, that is the remote repository that we created. So if you did that fork with us just a second ago and you copied that link, if you could just navigate to a different folder than the one that you already had locally. So if you need to make a directory, you can do mkdir and then a name. We could go inside of that folder and do your Git clone. Does that make sense, Xing? You just have to go somewhere else. Okay, yeah. All right, Arian, do you mind checking for me again if there's some thumbs up?
Not right now. I couldn't see thumbs up.
Okay. I'm going to give you guys a few more minutes. Again, navigate to that response scripts folder. How do I clone my feedback? So you did the fork, and then you got that link from the GitHub website, and you did a Git clone, which brought all that your copy of all that code down. Then you navigated to inside of the repo to session 3 and then to response scripts. And then you created a script inside that folder, and that's all we've done so far.
Travis, can I ask a quick question?
For sure.
Can you explain the difference between the commit step and the push step? I know push is what brings it up to the cloud, but why exactly do you need to do the commit step, and you have to do a commit step every time prior to pushing?
Yeah, so it's an organizational tool basically. So whenever you're making a lot of changes, say you had a full day's work of working on a code base, not every change that you make is going to be associated with one another, right? If I'm doing machine learning and then doing some data engineering on the same day, I'm not going to want to put all those changes in one bundle or one commit, right? I would take it and put my machine learning changes in one commit, and then the message for that commit would be, a description of what I did machine learning wise. Then I would bundle the data engineering changes into another commit and have a message that's, what I did data engineering. And then, so you can stage all of those up throughout your day and then have one single push that takes all those changes and reflects them in the remote repository. So the commit is just kind of an organizational bundling tool, but it doesn't have anything to do with your remote repository. That's kind of like committing to the changes locally, because you can uncommit things, but it's a whole process. So you're kind of committing on, like, saying, yes, I'm going to make all those changes locally, and here's how I'm going to organize them. And then you do a git push to say, okay, I'm done with that. Here, remote repository, take all my changes. Does that make sense?
Yeah, that was great. Thank you.
Sweet. All right. So again, can I get a thumbs up in the chat? And if everyone could check if you were able to make your response script in this repo. And also, this is something that I should have said. If you can name your response script your name _ response.py. So if you've already made something that's not that, if you could do mv, which is move, then type whatever name of the script that you created was. So example response was what I created, and change that to your name _ response.py. If we ls, we can see that that has changed to your name response. Sorry about that, guys. I forgot to mention that. So just rename that file however you would like to rename it with your name _ response. All right, so then we're going to go through those steps that we did in the other repository. So we're going to do git add your name .response. How do I set it to session 3 GitHub? So after you did the Git clone, you can cd. So you do cd into the repo, then you cd'd into session 3, cd, which is just change directory into response scripts, and that's where you created your response file. So again, we have our response file created. Then we're gonna git add your response.py. And if we do git status here, we'll be able to see if that change is ready. So we have new file, your name response. I'm going to clear so we're able to see a little better. So git status is ready for that. So now we're going to do a commit. So we'll do git commit -m, open quote, and then we're going to say something, doesn't really matter. Here is my response, Travis. Then we'll hit enter. Do another git status. We can see our branch is ahead of the main branch by 1 commit. And we're going to do git push. Again, we'll need to enter our thing. Enter our username and password. So it'll be intro to computing -321. And then we'll need to copy paste in our fancy code. Hit enter. All right. Then if we go back to our GitHub and refresh, we can see that a commit was made. Here's my response, Travis, and it'll be whatever you put on there. So hopefully you were able to make that. And then what we're going to do is we're going to give my personal GitHub, who owns this repository, a pull request. So we're going to say we want to contribute. And we see that our branch, which is this remote repository, is 1 commit ahead of the one that we forked it from. So we're going to do open pull request.
Travis, there's a question. Not in the chat. Someone raised his hand.
Hey Fred, feel free to unmute.
I got an issue here when I tried the next command you said. When I typed my token, it said that I don't have permission to do that.
All right, did you, when you did the Git clone, did you do it off of your fork, like after you So we were here at Fido Oracle AG2PI introduction. And
Yeah,
then,
I did.
Mhm.
But now when I try to git push, it says the remote permission on Python Oracle
Yeah.
AG2PI blah 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 denied to my username.
Yeah, so let's try going back to your profile on GitHub, and then you'll see you have an additional repo now after you did the fork, or you should see one there.
Let me check. My profile. No, I think I missed a step here then. It is not
For
appearing
sure.
to me.
So what it's doing is you're trying to push changes directly to my repository, and you don't have permissions in my repository. So it's like, hey, what are you trying to do? You can't do that. So that's why we have to go. I'll send the link again. If you go to this repository, and then you have to click fork in the top right, and that'll make a copy for you that you do have permissions on.
Okay, I'm gonna try that. Thank you.
Yeah, for sure. So then once you get that fork, you can go to your version of it, and it should say your username in the top left. And then you can do the code, you can do the Git Clone and create your file in the responses. Does that make sense?
Yeah, it does. Thank you very much indeed.
No problem. And it would be the same thing for you in the chat that is having the same issue.
I missed that, Abels. I apologize. Can you show me where the fork is again?
Yeah, for sure. So if we go back to the Fido Oracle AG2PI thing, in the top right here, there's a button that says fork. Do you see that one?
I got it. That was great. Thank you.
Sweet, no problem.
So now I have to restart every step I've done to here.
Yeah, you just
I
have to
gotta
do the
Git
Git
Clone again.
and then make your changes.
Pardon me?
So you'll do the you'll go to your repo and you'll get this link here. You copy it and then do that Git clone. So you pull the repo down that we did just a second ago.
All right. Okay.
And then you do the whole commit, add, commit, push cycle to get it up
Sure.
onto there.
All right. Thank you. Give me some time and I'll do that.
For sure. And Arian is going to do a whole machine learning presentation after this, and I'll have have it up here. So if you guys do end up doing your commits or contributions after that, I can do that. So anyway, we're gonna, after we've made this commit and we can see it here reflected on our remote repository, we're gonna click contribute and open pull request. Here we can see what changes we made. Then we're going to do create pull request. And here you can see we're saying we want to take our branch that we made and merge it with the Fido Oracle branch, which is my repository. So we're going to create a pull request. And we can add some stuff in here if we would like. Usually if you were doing this for a collaborator, you might leave what you did for them or did with them. And you're going to hit create pull request. All right, and then you are done, and then the person who owns the repository will get a notification that says, hey, someone has opened a pull request and they want to merge their code with yours. So I'll show you what that looks like for your collaborator. So here I am on the same repository that you guys just forked, except on my account that has the permissions. So I can see that 17 of you have forked it. So awesome. I'm glad some of you were able to do that. And then once you guys start doing those pull requests, I'll get a notification right here that says I have one pull request open. And I'll say, oh, someone changed my code some way. Let me check and see if I want to incorporate their code into my repository. So I can click on that. And it says this branch has no conflicts with the base branch, which means it's not going to mess my stuff up. It hasn't changed something that I've also changed, which will be good to go there. And so I can do merge pull request. I can confirm merge. And now the from where I had made that change in my other profile is reflected in the overall branch. Does that make sense for everyone? And again, all these steps are outlined in our README for this session. Of course, it's not going to tell you how to do the merges because that's something your collaborators would do, but it'll show you everything of how to do pull requests and how to do version control for just yourself. Oh, and it looks like I've got another pull request. So Jerome has given a response. So I can see, if I go here, I can check and see what files he changed. And you say, good job, thank you, Jerome. So I'm gonna go back. And then I'm gonna choose to merge Jerome's pull request as well. Sweet, so now we can see that I merged a pull request from Jerome, and y'all can keep giving those and I'll merge them and you can see you can contribute to our session. So appreciate it and thank you for the feedback. If you guys have any more questions, let me know. And feel free to put them in chat and I can answer them. And then I'm gonna hand it over to Aryan for our last portion of the workshop, which is what we didn't have time for last week, which is the machine learning portion. So before I hand it off to Aryan, does anyone have any more questions that they'd like to ask about version control with GitHub?
Can you show once again, just the commands again for me to complete the last commands, please?
Yeah, for sure. So let's see, where would you be at? You would be at this step where you haven't cloned the repo. And then I would go to.
Yeah, I've already done my response. So I just need the steps to upload it successfully.
Gotcha. So
I remember it's pull and status, but I don't really know the order.
Yep, so you'll do git add the name of your file. Then you'll do git commit -m, and then you'll type a message. Then you'll do git push. Then you go over to your repository on GitHub and press contribute, and then you follow the prompts there. And I can type those in the chat for you. And the person having the error again, if you want to, I'll put you in a breakout room once Aaron gets started and we can get it sorted out.
Oh, thank you. Now I think I did that. Now I think it worked.
Let me check for you, Fred. I think this is Fred. Synapsis, is that your username?
No, it's Fred48.
Okay, well, I'll let you know in the chat, Fred, when I see your pull request come through.
All right, thank you.
No problem. And with that, I'm going to head over to the breakout room in the support breakout room and see if I can help you guys out that are having problems. Please join that support room in the bottom right, and then hand it off to Arian if you want to get started.
Thank you so much, Travis. Okay, so hi everyone. For those of you who weren't in the previous sessions, my name is Arian. I'm a PhD candidate at the Department of Computer Science at the University of Arizona. I work on applications of machine learning and computer vision in remote sensing, plant science, and agriculture. So in this part of the third session, we are going to go over some basics of machine learning, and using all of the tools that we've learned, we're going to accomplish some interesting tasks. We're going to solve some interesting problems together and learn about some basics of machine learning. With that, let me share my screen. Can everyone see my screen? Can you show me a couple of thumbs ups? Cool.
Looking good.
Perfect. Perfect. Okay, awesome. So during this part, whenever you had a question, you can stop me. You can type into the chat. So let me know if you have any questions. Okay, so well, if you want to talk about machine learning, that's going to require a whole series, a whole workshop series. It's a very broad topic, but in this part of the last session, I'm going to go over some basics of machine learning tasks, machine learning problems. I'm going to understand what they are, how to solve a couple of them, and then that will give you a clue to do that for your own data. If you have any interesting data, you want to find patterns, you want to do some interesting things with your data, we can use the stuff that you're going to learn today, and with the other links that I'm going to share with you, you would be able to do some interesting analyses on your data. So generally, when it comes to machine learning, we are trying to use the things that the computers know, and the data and the labels and the annotations that we have on our data. We are going to use all of those in order to make the machine, make the computer understand something about our data, find patterns, detect objects, feed lines through data, find correlation, and all those stuff. Generally, machine learning problems or machine learning tasks are separated or divided into two different groups. We have supervised learning or supervised machine learning, and we have unsupervised machine learning. There are other groups of machine learning tasks, which is beyond the scope of this session, which we're not going to talk about. But generally, in supervised machine learning, we have some data and we have some annotations and labels for that data. And the computer is going to use those annotations, use those labels to learn something. So imagine that you have some pictures and you have some names of the objects in that picture. Those names, those objects are going to be the labels that we have, or the annotations. And you're trying to ask the machine to learn that it gives you the name of the object, of the object that's present in the picture, by giving that picture to the computer. So that's going to be your task. That's one of the tasks in machine learning. So generally, again, if you have labels associated with your data, that's going to be supervised learning. On the other side of the spectrum, we have unsupervised machine learning, which is basically you have some data, but you don't have any labels. You just have some data points in a space. And generally, in unsupervised learning, we are trying to find patterns without knowing any labels. So say you have some data points in a 2D or 3D space, you want to cluster it into different groups. So that's going to be the clustering task in unsupervised machine learning. Okay, so within supervised learning, we have different types of problems, different types of tasks. And here in this picture and in the bullet points, you can see some of them. The first one, and the classic one, is called regression. So in regression, we're trying to oftentimes find relation between some variables that we have in our data. Say you have patients' data, you have their height, you have their weight, you have their age, and you want to find a relation between, for example, the chances that they're going to get diabetes based on these factors. For example, that's just a very basic example. And when I say the chances that they're going to get diabetes is basically you're trying to find a number just between 0 and 100 that says, okay, this person is very likely to get that. Or another classic example is just finding the price of an apartment based on the square meter and other factors. So whenever you have a numerical value, which you're going to estimate based on some other features or parameters, that's going to be regression. We have different type of regression, which we're going to discuss in this session, but generally that's the nature of this problem. Other types of problems, you have classification. So in classification, you're trying to find, instead of just finding a numerical value, a real value, you're trying to categorize your data into different classes. Say you have this picture, you want to see whether the object of inside the picture is a cat or a dog or a giraffe. So that's going to be classification. We have localization, which oftentimes comes with classification. In localization, we are trying to find bounding boxes around the object in the picture. So that's the only task that we have. So that's going to be localization. Another problem or task in machine learning is semantic segmentation. So given a picture or a video, we want to semantically segment pixels of that picture into different groups. So here on this part of the picture, we have a picture of a giraffe, and we want to say what each pixel, which class each pixel belongs to. So as you can see, the yellow pixels are the animal, the giraffe, and the red ones are the sky, and so on and so forth. Another type of segmentation is instance segmentation. So in semantic segmentation, we only care about semantics of the objects, but in the instance segmentation, we're looking to understand or make a distinction between the different instances of the objects. As you can see here, you're finding semantically, you're finding semantics of these pixels. This is dog, this is dog, this is cat, but you're making a distinction between these two instances of the dogs. Another task is object detection, very similar to instance segmentation, but this time we're not just doing like classification for each of the pixels. We're just finding a bounding box around each of the objects. These are supervised learning. Again, for unsupervised learning, we have the clustering task. So given some data points, we want to cluster them into two different groups, but here we don't have any labels. We just given the data, and we need to do the clustering. Clustering is another task that we are going to talk about in this session if you have the time. But if you're interested in other types of machine learning, which we're not going to cover in this session, you can follow this link, which I'm going to share with you. Give me 1 second. If I edit this, I can share this link with you in the chat. If you're interested, this is another AG2PI workshop that we had before. And if you're interested to learn about neural networks and machine learning and segmentation and all that stuff, you can watch this workshop. Okay, great. So before I move on, I'm gonna this notebook is in the session 3 folder of the repo that Travis shared with you and we shared with you during this session. If you're not able to run this on your Visual Studio Code, we have this. Let me get the link from here. We have this link in for a notebook in Google Colab. We can open it up. I'm going to send it into the chat. If you want to follow along with me, you can also run this code on Google Colab. Okay, let's move on. So during this session, we're going to learn and work with SciPy and scikit-learn packages to do the machine learning tasks that we're going to do. We are also going to use some other packages that we used before, like NumPy, OpenCV, and all of those packages. So let me know if you have any questions about that. With that said, let me begin by introducing linear regression and do some basic things with linear regression. So basically, when we talk about regression, as I said, we are trying to find relations between some variables, which we call them independent variables or features in our data, between those and a dependent variable. Again, classic example, say you have the area of an apartment and you want to find the price. So the area of the apartment is going to be an independent variable or feature of your data, and the price is going to be a dependent variable, which is dependent on the area of the apartment. And we are going to find a relation between those two. When we talk about linear regression, usually that relation is linear. When we say linear, it means that we are almost trying to fit a line through all of the data points in order to find that relation. So it's going to be a linear relation. I'm not going to the details of the mathematics, but if you know if you remember from the courses that you've taken probably during your studies, when we say linear regression or linear operations, we're talking about not having any multiplication between our independent variables, not having any exponents between those variables. We are just having some simple additions and subtractions between the variables. So that's going to be linear operations. Okay, the reason that we do linear regression, as I said again, is to find the relationships, and also at some points there might be some prices, or sorry, for that example of like apartment area and the price of the apartment, there might be some numbers that we're going to get from the user, some queries that we don't have any data for, but we can estimate a value based on the things that we know from before. So that's another reason that we do linear regression. In order to assess how a linear regression is doing, or how good a linear regression is doing its job, we have this value or this formula of R squared, which tells us the goodness of the fit of that line. It's basically the percentage of the variance in the dependent variable that the independent variables can altogether explain. I'm not going to go into the details of that, but generally this R squared is a value between 0 and 1. And if it's get closer to 1, it means that our dependent variables can explain our independent variables can explain the dependent variable to a good extent. Okay, now let's move on to our hands-on portion of this part. So here, this cell, I'm just importing all of the packages that I'm going to use. We are using Matplotlib, SciPy, scikit-learn, different submodules, Pandas, NumPy, and CV2, which is OpenCV. We've already talked about all of these in the session 1. If you're interested, you can follow the link and find the materials in the session 1 folder. So let's begin by running this. When you do that, it probably asks for you to choose one of those kernels. So I'm gonna choose this one. If you have conda packages, you might wanna choose the kernel or the conda package that has all of these Python packages installed. So now let's move on to the next cell. So here in this cell, I'm basically what I'm trying to do is to generate some random data. And by random data, I mean some X and Y two-dimensional data. And I'm somehow defining the relation between that data. So I'm generating here in this line, I'm generating 50 random numbers. And in this line, I'm multiplying all of those numbers by this value, and I'm adding a random node to that. This is, if you remember the formula of a line, this is basically similar to just having a line with a random intercept. And this is that formula of the line. So not going into the details of that, this would generate some random data in a two-dimensional space for us. And I do that and then print the data. So that's going to be the X, that's going to be the Y. In the chat or in the using the thumbs up, can you let me know if you were able to run this part either in the Google Colab or within this Python notebook? Okay, I see some thumbs up. If you guys have any questions, just let me know. Otherwise, I'm going to move on. Perfect. Okay, so to recap, this is a linear regression formula. We have our X as the independent variable. That's going to be the data that we have. It's going to be the input. In our apartment example, this would be the area of the apartment. And we're trying to find A and B. A is our like the line slope, and B is our intercept or y-intercept. And this Y is going to be the actual price of the apartment. So we have X, we have Y. Y is our target. We are trying to find A and B in a way that in the future, if someone asks for the price of an apartment with an area that we don't have in our data set, we are able to find an approximation for that person and just provide that number. The way to do the linear regression is very simple. We have this stats submodule from SciPy. We just say stats.line_regress, and we provide the X and the Y. And once we do that, we're going to get the results here, and the R value is going to be giving us within this package. That's going to be, if you raise it to the power of 2, that's going to be our R squared. So let's run this cell, and then following from this line, I'm going to plot the points all together with the line. I'm using the intercept and the slope of the line to basically draw the line. And once we run this, that would be our data. So here, these are the data points. The blue dots are going to be our data points that were generated randomly here. So again, X is going to be some random numbers. Then we use the formula of a line to somehow synthetically generate the data that somehow follows a line. And then we are trying to feed a line to that using this linear regress here. So by show of thumbs up, let me know if you were able to run this cell. And if you have any questions, just unmute yourself or tell me in the chat. Okay, cool. I'm seeing a couple of thumbs ups. That's great. So move on to the next part, which is nonlinear regression. So as I said before, if we have nonlinear operations between our independent variables, so say we have, again, one variable, which is X, but here we have like some nonlinear relation between the X and itself. Or if you have two different independent variables, say the area of the apartment and the latitude and longitude of the apartment, which is going to be two other numbers. And if you have some independent, some nonlinear relation or operation between these independent variables, then our regression is going to be nonlinear. And we're not going to be able to use that simple formula to fit a line to that data. So when I say nonlinear relation between the data, it means that the actual model that generated the data, the actual underlying ground truth model, is a nonlinear model. And in that case, we have two options. We can either do some nonlinear regression, which is oftentimes a difficult thing to do, or we can use a technique which is called the kernel technique to convert that nonlinear operation into a linear operation. Say that your data follows a parabola function. In that case, since you know that there is an exponent, like a squared relation between your independent variable and itself, then you can somehow change that problem or change your data or transform your data into a different space, which in that space, the relation between the dependent variable and itself or other dependent variable is going to be linear. I know this might sound a little bit vague if you haven't taken those courses and classes. The goal of this session is not going into the details of the math. I'm just mentioning some names, some few names for you guys. So if you're interested in learning how to make a nonlinear regression linear, is basically by using the kernel technique. And that kernel is basically transforming your input space into a different space. Within that space, we don't have any multiplication, we don't have any exponents, and that space is basically going to be a linear space. We can fit lines or planes or hyperplanes to that data in that new space, and that's going to be making our lives much easier. So if you have questions here, you can email me if you want to know more. If you want to go into the details of that, we can chat later. You can send out emails. Otherwise, let me explain with a very basic example how this linearization technique is going to work or is going to happen. So imagine that you have this absolute value function. You guys are familiar with that function. Basically, absolute value function, if you give it a number, if it's more than 0, if it's above 0 or 0 itself, it's going to spit out that number, the same number for you as the output. If it's below 0, it's going to multiply it by -1. So that's going to be the shape of this function. You all know that this is a nonlinear function. And if this function actually generated our data, then the relation between our data and itself is nonlinear. Again, this might sound vague, but in simple words, we cannot fit a line into this data, into the data that's generated by this function. But there's a way that we can transform the data into a linear space. If we understand the nature of our data, since here we know on the nature of our data, we know that it's generated by this absolute value function. We can use this other function, which is called the step function or the sign function, which is basically anything above 0 gives us 1, anything below 0, it gives us -1. If we use that function and multiply this function by the absolute value, if you do the math, you're going to get a line. So this is somehow the kernel technique. Now we can use kernel technique in regression. We can use it in classification. Sometimes our data is, it's in a way that we cannot separate the classes with like a simple plane. In order to make that happen, we sometimes change the dimensionality of our data. We just take it into a different dimension. We use kernel techniques. We apply different types of kernels in order to make our data separable. In regression, we do that in order to be able to fit a line through our data into that new space. So that's generally some intuition for you guys to understand what kernel is. If you're interested, again, let me know at the end. So now let's generate some data, which is not going to lie on a line. And I'm just running this cell and generating that data for you. So we have some, for X, we have the numbers from 0 to 30. For Y, we have these values here, and that's going to show us the data. As you can see, if we fit a line through this data, our fit is not going to be accurate. R squared is not going to be high. But if we fit a polynomial to this data, or a polynomial function, or another type of nonlinear function, then that fit is going to be very accurate. But doing nonlinear regression is difficult. What we're going to do instead is converting our data or taking our data into a different, basically space, which is going to be taking the data into the polynomial space. To recap for you, or to just basically give you some idea of the formula of a polynomial, if you remember, that's going to be the formula of a polynomial. So we have our input x raised to different powers from 0, 1, 2, all the way through the degree of the polynomial. We have some coefficient multiplied by that. And here, in our polynomial feeding or polynomial regression, we are looking to find these the values for these coefficients, the a sub I. And we have our x, it's our input, we raise it to different powers. And using that, we were able to feed a curve to this data. So how this relates to the kernel technique, here we have x as our input, but we are raising it into different powers. So it's a nonlinear operation between x and itself. And but if we like use a fixed set of terms with fixed exponents, we can use those notions to convert or transform our data from the input space, which is x, into a different space which contains x to the power of 1, x to the power of 2, and all the way to the degree of the polynomial. If we do that, now we're dealing with the data in a different space. Then the relation between the input of that space and the coefficients are going to be linear. We don't have any nonlinear relation, and then we can use linear regression to estimate those a sub i's in that space. Okay. Do you guys have any questions? I see some. No questions. Cool. So let's move on to this cell. So here in this cell, I'm using the polynomial features to define a polynomial transformation or polynomial feature. So I'm saying that I'm going to have a polynomial function with a degree 12. So we're going to have like 12 terms here or 13 terms. And then here I'm just trying to transform my data from the X space into this new space, which contains 13 different features. So that's the kernel thing. And right after that, I'm doing the linear regression. I'm just fitting that poly features, the new inputs to the target Y. And then at this point, I'm just doing the simple prediction of the Y values. So let's run this. So you have a question?
Yeah, it says, Jonathan asks, are there limitations to the types of space we can transform data to while maintaining interpretability?
Well, there's no limitation. If I understand the question correctly, the space that you can transform your data to, there's no limitation to that. You can transform your data using any functions. You can use sine and cosine. You can use exponents. You can use log. It depends to your data. So one of the things that you have to do first is to somehow visualize your data if possible, and then find correlation between different features. And by understanding your data, you kind of realize that, okay, I see some like parabola function between these two variables, so I can transform that part of my data to that space and things like that. But there's no limitation, but you have to be careful. You can apply as many kernels and as many transformations as possible as available, and then that's going to be extensive search space for you to find the best kernel. So analyzing your data first would be the best thing to do. I hope I answered your questions. Otherwise, let me know if I didn't understand it correctly. Okay, cool. Now we ran this cell. It generated the transformation. It transformed our data into the new space, and it fit the linear regression to that new space. And now we have our predictions, Y predictions, which are going to be used for drawing the line. Just to show you the new space, I'm going to print out the poly features here. So here, as you can see, this is some numbers, but take a look at the dimensions. It might not be easily like visual, but here, if you take a look at this, you can realize that we have 12 different features instead of one. And these are different values for different data points that we have. So basically, we transform our data into that new space. So now let's see what's the result. So if I run this cell, it's going to plot the points and it's going to plot the line that we just fit, or not the line, the polynomial function that we fit into that data. So using this line, if someone asks for, so imagine that this is the area of the apartment and this is the price. If someone asks about the area that lies here, since we don't have the data point over there, but we have this function, we can use that function to provide an estimate. So that's the whole goal of regression. Let's provide another example. This is a real world example that we have in our project. We have air temperature data in our field in Maricopa, and oftentimes we want to find relation between that temperature. We want to find temperature between the times that actually the sensor doesn't give us any exact temperature, so we want to estimate that. So I have this data, that CSV file here that contains the temperature and the humidity of just one single day. By doing this, by reading the CSV, we're just loading data from the CSV into a Pandas format. So that's going to be our data. This first column, the first column is going to be the hour. The second column is going to be the temperature, and the third is going to be the humidity, which we're not going to use here. Now let's convert that data into NumPy and then plot the data using this. As you can see, this shows the changes in the temperature in Maricopa in the field in a day. By show of thumbs up, let me know if you guys were able to finish the previous part and if you were able to run all of the cells up until here. If you have questions, always, you can stop me.
Can you see the other participants, Eric, Brian?
Yeah, I don't see any thumbs up. So if anyone has any problems, just let me know.
I got an issue with the file since the last block of line, because it says I don't have the data.csv file here. So I think it's missing in that I'm using Google Colab.
Are you using a Google? Okay, you're using Google Colab. So one thing that I can do, which is not a clean way of doing this, is I can share the data with you here. I can share the file with you, but you have to, if you remember from the first session, you have to mount your Google Drive to Google Colab. If you remember how to do that, I can share the file with you.
Yeah, all right.
Yeah,
that's
otherwise, let me just, I share this data in the chat for you guys. And if you have, you can just load that data. And the way to load this data is by using the NumPy. You can say NumPy.array. I'm just putting it into the chat. And you just paste that data that I just sent to you. And then that's gonna convert that list of lists into a NumPy array. I hope that works for you. This is a fast solution, but not a clean one. Okay, let me know if you were able to run that. If you have other questions or if you have other problems, just unmute yourself and let me know. Okay, since we're getting close to the end of this session, I'm going to speed up a little bit. So here, what I'm trying to do is basically doing the same thing. I'm creating a polynomial feature. I'm feeding that polynomial into our data. I'm first converting our data into that space, then feeding the polynomial feature to that. And then first, I'm just predicting a value for the temperature of a specific hour, which is like this time of the day. So that's going to be the output that we get here, and also the fitted polynomial to this data. So let's run this cell. As you can see, that's going to be the output, and that number here is going to be the temperature at around like this time, somewhere around here. which is 9.09. Okay, so I'm gonna move on to the next part to just give you a little bit of intuition about overfitting. So in machine learning, one of the concepts that we often like talk about is overfitting, and that is providing too much power for the model. And if you do that, it's not going to learn beneficial things. It's not going to learn the actual correct patterns, but it basically memorizes the data, which is not good for us. So here, imagine that we have like a polynomial with like degree 10 or 100 or like 200 or something. In that case, if you know the math, it's going to go over all of these points, and that's going to give us a very bad polynomial with a lot of fluctuations, which is not going to be good for estimating values that we don't have. So that's somehow the concept of overfitting in regression. So in order to show that, I'm going to generate some data, generate some random data. I'm not going to explain what these are, but basically I'm generating the data from a polynomial function that I know, and I'm going to add some noise to that data. Let's generate that and plot it. So that's going to be our data. This is the function that we use to generate the data. These are the data points with some noise added to that. So now let's feed a degree 4 polynomial to that and see what it does. So when I run that and then plot it, you see that this is going to be the degree 4 polynomial. It's somehow close to our to that function that we used. But as you can see, it's just trying to fit to as many points as possible. And if we want to get an estimate for a point that's like perhaps around here, like say we want to get an estimate for 10, that's not going to give us a correct estimate. That's very incorrect, because the degree of the polynomial is more than the thing that we need. But if I change that to 3, I expect to get a slightly better function. As you can see here, that the slope that goes up is slightly smaller. If I do 2, that's going to be even better, a better estimate. So if I increase the degree of polynomial extensively without understanding our data, that's going to provide a very inaccurate function. It might fit through our training data, but for unseen data, it's not going to do a good job. So that's all about this part, the regression. I wanted to go over some clustering materials, but since we're like we ran out of time, I don't think we can cover this part, but we provided this to you guys. Again, clustering is putting the data into different clusters and into different groups automatically without having a label. Here, I explained about some different types of clustering with some examples and pictures. I explained how k-means works. You guys can follow this part. And using these code that we have, you can actually see how the clustering works. And at this part, I'm going to, I was planning to provide some real world example of segmenting images using clustering, which you can run yourself and see how it works. Again, all of the data, all of the pictures and figures are available in our GitHub repo. You can access that. And with that said, before we finish, first, I would like you to consider filling out the survey that you're going to get by leaving the Zoom link. So please do that. We're going to use that to, or AG2PI people are going to use that to improve the workshops. And at the end, before we finish, I would like to give our thanks to the whole Phi Oracle team. I would like to thank the Department of Energy, Division of Biological and Environmental Research. I would also like to acknowledge Department of Energy Advanced Research Projects Agency, Energy and Cotton Incorporated, and most importantly, the AG2PI, which is supported by NIFA, for providing this opportunity for us to have these workshops. Thank you so much, everyone.